Hello, all, and welcome to another installment of the Visionry Presents. I'm Greg, your host, and as you can see, we'll be learning about PTSD in your brain. And as always, I'll try to make this as understandable as possible. So let's begin. Well, first, let me get the specs so I can see what's going on here. All right, somebody woke up on the wrong side of the bed this morning. We all know that comment, the one that already makes you feel any more gracious to the world or the person saying it, or at other times, you may feel particularly gracious and sunny for no reason at all. This is how our emotions affect us. Many regions fundamental to emotion are buried deep in the most primitive part of the brain. It is thought to have been among the first to develop in the human species. Called the limbic system, it is the major primordial brain network involved in emotion. It's a network of regions that work together to process and make sense of the world. And here's a quick look at here's a view of the limbic system and a couple of the other structures that we'll be talking about today, namely the hippocampus. The hippocampus, which is right in this area right here, the amygdala, right in here, and over here in the prefrontal cortex, we're going to be talking about another area of the brain called the ventral medial prefrontal cortex, which I'll explain a little later in the presentation. So let's continue. The limbic system also regulates biological functions in line with our emotional state, such as accelerated heart rate and sweating triggered by feeling flustered. Basically what happens when you have your fight or flight system is activated. Being so old, the limbic system is rather primitive. In day-to-day life, it's controlled by some of the newer networks that coordinate how we think and act, so our behavior is conducive to achieving long-term goals rather than always going where our emotions take us. The limbic system is made up of structures such as the hippocampus and amygdala, both of which we looked at, and other structures as well. If you've seen my addiction show, then you may remember this information, or if you had missed it or don't recall, I'll recap. So as mentioned, the almond-shaped amygdala attaches to emotional significance to events and memories. That's right in here. The amygdala also has been shown in research to perform a primary role in the processing of memory, decision-making, and emotional responses. It mediates many aspects of emotion and memory. Although historically the amygdala was considered to be involved primarily in fear and other related emotions to aversive or unpleasant stimuli, it is now known to be involved in positive emotions elicited by appetitive or rewarding stimuli. We'll talk about a little bit about the hippocampus. I also introed in my addiction show. It seems that where the name came from the Greek, it seems that the physical aspects of the hippocampus has a distinctive curved shape. If you look right down in here, you can see it. And has been likened to the seahorse monster of Greek mythology, where hippo means horse and camp means for sea. So in English that translates into seahorse. The hippocampus also plays a critical role in the formation, organization, and storage of new memories, as well as connecting certain sensations and emotions to these memories. So, have you ever noticed how a particular scent or a song may trigger a strong memory? That's your hippocampus at work. The hippocampus is thought to be primarily involved in storing long-term memories and in making those memories resistant to forgetting, and also responsible for the processing of long-term memories and emotional responses. It not only assists with storage of long-term memories, but it also responsible for the memory of location of objects and people. We wouldn't even be able to find where our house is without the work of the hippocampus. And in Alzheimer's disease, which we've probably all heard of, the disease that affects elderly people and often results in loss of memory, has been proven to affect and damage this area of the brain. I'll also be introducing another part of the brain affected by PTSD called the ventral medial prefrontal cortex, which I mentioned a little earlier. And here's a little slide to help you understand where that area of the brain is located by breaking down the name. So as you can see here, ventral or ventro means at or towards the front of the body, opposite of dorsal, like dorsal fin on the shark, that's the back. Medial means pertaining to or situated toward the midline of the brain. And prefrontal cortex is related to the foremost part of the frontal lobe of the brain. And here's a little shot of a picture for you so you can see that's all right in this area. You get your amygdala down here and the hippocampus up there, but it doesn't show it. And the ventral medial prefrontal cortex is implicated in the processing of risk and fear. It is the region of the brain that is responsible for regulating emotional responses triggered by the amygdala. Specifically, this region regulates negative emotions such as fear that occurs when confronted with certain specific stimuli, things that make you afraid. Extensive neuroimaging studies of the brain of PTSD patients have shown that these regions differ structurally and functionally from those of healthy individuals. The amygdala, the hippocampus, and the ventromedial prefrontal cortex play a role in triggering the typical symptoms of PTSD. These regions collectively impact the stress response and mechanisms, the stress response mechanism in humans, so that the PTSD victim continue to perceive and respond to stress differently than someone who is not suffering the aftermath of trauma. Now that we've gotten a little bit of the brain anatomy involved out of the way, let's take a look at what goes on inside the brain of people with PTSD. PTSD is painful and frightening. The memories of the events linger, and victims often have vivid flashbacks. Frightened and traumatized, they are almost always on edge, and the slightest of cues sends them hurtling back into their protective shells. Usually victims try to avoid people, places, and objects. Remember that word avoid, or avoidance? These places, people, places, and objects that remind them of their hurtful experience. This behavior is debilitating and prevents them from living their lives meaningfully. Many victims try to forget the details of the incident, presumably in an attempt to lessen the blow of PTSD. But this coping mechanism has negative repercussions as well. Without accepting and reconciling with reality, they turn into fragmented souls. Although people often associate PTSD with veterans affected by the horrors of war, which was once referred to as shell shock, you might have heard that from the vets coming home from World War I or World War II, that they had shell shock. Well, in 1980, the afflictions of these soldiers, along with research on the psychological impact of trauma on Holocaust survivors, rape victims, and others, led the American Psychiatric Association to define a new condition called post-traumatic stress disorder, PTSD, in the DSM, the Diagnostic and Statistical Manual, The condition can develop in anyone who has experienced a dangerous, shocking, or life-threatening event. Although most people kind of think that PTSD can only occur if the event is very traumatic. But for some people that are more uniquely emotionally sensitive, as myself for example, find that even less traumatic events can cause what I like to refer to as your own personal brand of PTSD. It's not like full-blown PTSD with the nasty flashbacks and such, but there are certain PTSD symptoms that emerge because of certain situations. And as mentioned above, the number one symptom of PTSD is avoidance, like people, places, and things. Possibly where you may have had a negatively emotional charged incident happen, or where you may have felt very uncomfortable and now avoid that person, place, or thing. According to the National Institute of Mental Health, PTSD will affect about 7% of U.S. adults in their lifetime. The condition is defined by symptoms like panic attacks, depression, insomnia. But one of the most characteristic and debilitating symptoms of PTSD is something called flashbacks. Flashbacks are like walking nightmares. They are intense, repeated episodes of reliving the traumatic experience while you're fully awake. Flashbacks can come on suddenly and feel uncontrollable. They are more like a nightmare than a memory because sufferers often can't distinguish between the flashback and reality, feeling like the traumatic experiences happen again in the moment. Flashbacks are vivid sensory experiences. During one, a sufferer might see, hear, or smell things they saw, heard, and smelled during the traumatic moment. So there's the hippocampus at work. How can flashbacks be such an all-consuming experience? How can they transport someone back to the traumatic experience almost instantly? So let's look at how traumatic experience influence memory, and PTSD is a memory-based issue. So to understand what happens in your brain during a flashback, we first need to understand how memories are formed and how trauma disrupts the way this process normally works. And what happens to the different parts of the brain? Memory is a complex process that involves many parts of your brain. But to keep it simple, I'll focus only on three key players: the amygdala, the hippocampus, and the ventral medial prefrontal cortex. And I've made a little quick reference slide to help understand and remember the functions, which I'll refer to back as needed. So we'll look at that now. Okay. So it says here, the amygdala attaches emotional significance to events and memories. The hippocampus plays a role in formation, organization, and storage of new memories and connecting certain sensations and emotions to these memories. And the ventral medial prefrontal cortex regulates emotional response by controlling functions of the amygdala. So the amygdala, which is mentioned, is associated with emotional memory, especially the formation of fear-related memories. It evolved to ensure our survival by strongly encoding memories of past dangers you've experienced so that you can recognize and respond to those threats if you see them again. Basically, this was a survival mechanism back in our caveman days, saber-toothed tiger or the woolly mammoth chasing you through the savannah or the jungle. The hippocampus, the other region of the brain, heavily involved in memory, acts like the brain's historian. It catalogs all the different details of the experience, like who was there, where it happened, and what time of day it was. So it does this into one cohesive event you can consciously recollect as a memory. In your typical day-to-day life, your amygdala and hippocampus work together to turn your experience into distinct long-term memories. However, during a traumatic event, this system works a bit differently. Because you're in danger, your body's built-in fight-or-flight mechanism takes over and your amygdala is overactivated while the hippocampus is suppressed. So with the hippocampus suppressed, you don't get the context of everything that happened. From an evolutionary standpoint, from an evolutionary perspective, this makes sense. The process involved in building a cohesive memory are deprioritized, which they don't happen, in favor of paying attention to immediate danger that you need to run. As a result, your memory becomes jumbled. And we don't need to really have that anymore because we don't have tigers chasing us through the streets of Bennington. When the threat is past, you are left with a strong negative emotional memory of the experience, but you lack clear recollection of the context of the event. So no hippocampus, the hippocampus is suppressed, so you don't have that timeline, so to speak, of how things happen, or that there was how the danger was. So in other words, you may learn to associate individual sights, smells, and sounds with the event from the event with danger, but unable to recall the sequence of events clearly. Later on, if you encounter things that remind you of the traumatic event, like a smell or sound, for instance, that was present when it happened, your amygdala will retrieve that memory and respond strongly, signaling that you are in danger and automatically activating your fight or flight system when you really don't need it. This is why during a flashback, you start sweating, your heart races, you breathe heavily. Your amygdala has set off a chain reaction to prepare your body to respond against a threat. Obviously, it's not there, but it's ready to run or fight. Normally, when your amygdala senses a possible threat, your hippocampus will then kick in to bring things into context from past memories to determine whether or not you are really in danger. But because the hippocampus wasn't functioning properly during the traumatic experience, the context of the memory wasn't stored, and there's no feedback system to tell the amygdala the situation is different and you're really not in danger. Also, since the memory is retrieved without any context like where and when the experience happened, you might even feel like the traumatic experience is happening again. So you may be thinking to yourself, well, Greg, what's the impact on the brain here? Well, the answer, the most significant neurological impact on the brain is seen in the hippocampus. PTSD patients show a considerable reduction in the size of the hippocampus. So when a traumatic thing happens, there's no context. PTSD patients will, with reduced hippocampal size, lose the ability to discriminate between past and present experiences or be able to correctly interpret environmental context. And this triggers an extreme stress response when confronted with environmental situations that only remotely resemble something from their traumatic past. For example, a war veteran cannot watch violent movies because they possibly remind them of their trench days, because the hippocampus cannot minimize the interference from past memories. Trauma appears to increase the activity of the amygdala. This region of the brain helps us process emotion and is also linked to the fear response. Excuse me. PTSD patients exhibit hyperactivity in the amygdala in response to stimuli that are somehow connected to their traumatic experiences. What is interesting is that the amygdala in PTSD patients may be so hyperactive that these people exhibit fear and stress responses even when they are not confronted with stimuli not associated with their specific trauma, such as when they are shown photographs of people exhibiting fear. This is something that is referred to as amygdala hijacking, and it's a biological process that we have no control over. PTSD patients show a marked decrease in the volume of the ventral medial prefrontal cortex and the functional ability of this region, which is supposed to keep the amygdala in check. This explains why people suffering from PTSD tend to exhibit fear, anxiety, and extreme stress responses, even when faced with stimuli not connected or only remotely connected to their experience of the past. To sum up a little bit, the hippocampus, the ventral medial prefrontal cortex, and the amygdala are part of the neural circuitry that mediates stress. The brain views trauma as stress. The hippocampus facilitates appropriate response to environmental stimuli, so the amygdala does not go into stress mode unnecessarily. But when it's damaged, you have no choice. The ventromedial prefrontal cortex regulates emotional responses by controlling the function of the amygdala. So it's not surprising that when the inhibited hippocampus and the functionally challenged ventromedial prefrontal cortex stop working correctly, the amygdala goes into a tizzy. Hyperactivity of the amygdala is positively related to the severity of the PTSD symptoms. So the mentioned negative brain developments explain the telltale signs of PTSD: avoidance, out-of-control startle response to the most harmless of stimuli, frequent flashbacks, and intrusive recollections. Researchers believe that the brain changes caused by PTSD increase the likelihood of a person developing other psychotic or mood disorders like depression, anxiety disorders, bipolar, to name a few. Understanding how PTSD alters the brain is critical to empathize with the condition of the victims and devise treatment methods that will enable them to live fully and fulfill their true potential. But in the midst of such grim findings, scientists also sound the note of hope for PTSD patients and their loved ones. According to them, by looking at the pathophysiology of PTSD, they have also realized that this disorder is reversible. In fact, drugs and behavioral therapies have been shown to increase the volume of the hippocampus in PTSD patients. The brain is a finely tuned instrument. It is fragile, but it is heartening to know that the brain also has the amazing capacity to regenerate. Understanding what happens in your brain during a PTSD flashback can help you learn coping strategies. You can work with a therapist to identify triggers to your flashbacks, such as certain objects, people, or places. Then you can work with them to identify ways to respond calmly to these triggers through relaxation techniques, as well as cognitive and exposure therapies. While PTSD can be a debilitating condition, in some cases taking years for the survivor to be able to be stable and healthy enough to process the trauma, with appropriate treatment, it can be successfully overcome. The physical scars heal, but the emotional wounds stop the lives of these people dead in their tracks. They are afraid to get close to people and form new relationships. Change terrifies them. They remain forever hesitant to express their needs or desires to meet their creative potential. It may not always be apparent, but PTSD stifles the life force out of its victims. It is no use telling them to get over it because PTSD fundamentally changes the brain structure and alters its functionalities, just as we saw how addiction changes the brain as well. Remember, please remember, and as we learn, PTSD is no fault of the sufferer, just as we saw in addiction, except it doesn't carry the stigma that is associated with addiction. It's a biological process that no one has control over. Another disease of the brain, just as diabetes, high blood pressure, and cancer are other maladies. Well, folks, that includes the installment of the Visionry Presents. Thanks for your time, and I truly hope you learned a few things to help you or another on the path to a more normalized and joyful life. Coming up on the next installment of PTSD will be the science of happiness, a topic with a little less gloom and doom. And we see that there. And as always, again, I'm Greg, and if there are any questions, comments, complaints, or suggestions, you can email me at thevisionary@pm.me. Thanks for your time, and I truly hope you learned a few things to help you or another on the path to a more normalized and joyful life. Or maybe with these facts, you may have some compassion for those that have fallen prey to the brain changes caused by trauma and/or addiction. Bye for now, and hope to see you soon with my next installment on The Visionary Presents.